When Meta's employee tracking program was exposed, headlines screamed about privacy violations and ethical scandals. But that narrative misses the real story entirely. The initiative did not collapse because of a moral outcry from workers or legal pressure. It failed as an engineering project due to a fundamental miscalculation in how modern teams approach data collection. This case reveals why treating high-frequency human behavior as a valid training dataset for general-purpose models creates a trap that no amount of compute can solve, and it forces us to confront the brutal trade-off between raw data volume and actual model utility in production environments today. We often operate under the assumption that more data equals better intelligence. If we collect every keystroke, every pause, and every hesitation from human workers, surely we are capturing the essence of how people think? The reality is far less romantic for any engineer trying to build a robust system. Meta's program was shut down not because it violated privacy norms in a way that triggered immediate bans, but because the data itself proved useless for its intended purpose as a training signal. The core failure lies in what we call the data quality fallacy. While collecting keystrokes provides an abundance of raw volume, it lacks the deterministic structure required to train models that can execute complex tasks reliably. A recent empirical analysis of over 3,000 bugs found across major coding tools like Claude Code and Gemini CLI reveals a startling statistic. 67% of functional failures in these systems did not stem from hallucinations or ethical lapses. Instead, they stem directly from the gap between probabilistic model output and deterministic system requirements. When an AI tries to predict human behavior based on noisy input, it often generates outputs that work in theory but break when integrated into rigid engineering pipelines. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This brings us to a specific metric that defines the cost of this approach. In those same coding tool studies, 37.3% of all bugs were traced back to API misconfigurations and integration errors where the AI's probabilistic predictions clashed with strict system constraints. This is not a problem of morality. It is a problem of signal-to-noise ratio. The keystroke data Meta collected was high frequency but low fidelity, meaning the model learned patterns that looked like intelligence but functionally amounted to noise in a production environment. The situation becomes even more critical when we look at how humans actually interact with these systems. There is a phenomenon known as the authority trap, where users treat AI predictions as infallible guides for their own decision-making. In behavioral studies involving over 1,300 participants, researchers found that greater than 40% of subjects treated an artificial intelligence as a predictive authority capable of influencing their choices more accurately than their own judgment. The consequences of this reliance are measurable and severe. When users follow these algorithmic predictions instead of relying on guaranteed rewards or their own logic, they suffer significant financial losses. The data shows that the odds ratio for foregoing guaranteed value increases by 3.39 times compared to random framing. This translates into earnings reductions ranging from 10.7% up to 42.9% simply because users trusted a model trained on suboptimal behavior patterns over sound decision-making logic. This proves a critical lesson for any data engineer. Human behavior is inherently flawed as a training target if the goal is optimal performance. By treating typing and hesitation as gold standard signals, we are teaching models to replicate inefficiencies rather than solve problems. The AI learns that humans make mistakes, pause unnecessarily, or follow bad heuristics, and then it codifies those errors into its own output logic. Furthermore, the industry's obsession with collecting every possible metric often stems from a chase toward vague goals like artificial general intelligence. This creates what researchers call generality debt, where models become too broad and inefficient for practical application. Meta attempted to build a general-purpose model using data that was specific only to human typing habits without accounting for the signal required to make those actions useful in real-world software tasks. As we move forward, the engineering bottleneck is shifting away from creation friction toward verification quality control. We are witnessing what experts call instrumental dissolution, where traditional interfaces like keyboard input become obsolete primitives for knowledge work. The value of keystroke data diminishes because typing itself consumes a shrinking fraction of worker hours as multimodal AI takes over content generation and execution. The lesson here is not to abandon data collection, but to audit it with ruthless efficiency. Developers must stop assuming that volume equals utility. Instead, they need to focus on curating datasets where the signal clearly outweighs the noise. The future of engineering is not about building models that mimic human typing. It is about designing verification workflows for synthetic outputs that can be trusted in deterministic environments. Meta's failure was a textbook example of what happens when you prioritize data velocity over data fidelity. It cost them compute cycles, time, and trust without delivering the intelligence they sought. For practitioners today, this serves as a stark warning. If your training data reflects how humans stumble rather than how systems should succeed, no amount of optimization will fix the fundamental flaw in your MLOps pipeline. The path forward requires shifting our mindset from collecting everything to curating only what matters. We must prioritize signal quality over raw collection velocity and accept that some behaviors are too noisy to be useful for training general-purpose intelligence. By focusing on data curation that improves model utility rather than chasing AGI metrics, engineers can build systems that actually work in production without the hidden costs of bad data integration. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.